Hello everyone, this is the first lesson recording for IM1, January 22nd, 2021. What are we doing today? We are going to be reinforcing geometric sequence equations. Then we're going to leave sequences for a little bit and then revisit linear equations and different ways of writing a linear equation. Alright, so let's go back to geometric sequence equation. If you have not already taken these notes down, you should be taking the notes. So the general formula or the equation for geometric sequence is this: a sub n is equal to a sub 1 multiplied by r to the power of n minus 1, where a sub n is referring to the nth term, the value of the nth term. A sub 1 is referring to the value of the first term, and r is the common ratio, and n refers to the position number. Okay, so if you're looking for, say, 6 value, then you can substitute n to be 6. So a sub 6 is going to be whatever these values are, and it's going to be 6 minus 1 and so on. So you can use this to calculate any term value a sub n in the sequence with the position n. So this is what is going to be really useful for you. Okay, to go back to our decimals activity from last lesson, one of the things that you should have noticed is that with geometric sequence, what you're doing is you're multiplying the common ratio over and over again to the original first term. That's what you're doing essentially. And repeated multiplication can be represented as exponents. So here are the exponents. So here you're multiplying by 3, the common ratio once. You're multiplying 3, the common ratio 2 times, 3 times, 4 times, and so on. And that can be represented instead as 3 to the power of 4 and so on. Okay, notice the fact that when whatever the n value is, the position number is, what you're multiplying by the common ratio by is always going to be 1 less than what the position of or the term number is. Okay, so comparing this 9, the exponent 9, to the term number 10, okay, this is going to be always 1 less than. So then we can come up with more generic formula by, say, if the term number or the position is n, then what's happening is really 0.25 multiplied by 3, all raised to the power of not n but n minus 1. Whatever n was, we're going to raise it to the power of n minus 1. So the general formula for this sequence becomes a sub n is equal to 0.25 multiplied by 3 to the power of n minus 1. And you can use this again to calculate any term value. Say if I wanted to figure out, okay, what would be the 20th term value? What would be the 17th term value? Or what would be 215th term value? I can use this equation. So then, writing geometric sequence equation. What is the equation for sequence 3, 6, 12, 24, and so on? First thing you need to do is establish that this is a geometric sequence and not arithmetic sequence. Okay, so how do we establish that? We establish that by making sure that the ratio between any number divided by the previous number is going to be the same. 6 divided by 3 is 2, 12 divided by 6 is 2, 24 divided by 12 is 2, and so on. Now that we've established that, we can use the geometric sequence equation where it says a sub n is equal to a sub 1 multiplied by r to the power of n minus 1. So to find the equation for this sequence, you need to first find the common ratio, and that's going to be the second term divided by the first term. Or you could have used the third term divided by its previous term, which is the second, so 12 divided by 6 or 24 divided by 12, they're all going to come out to be 2. Okay, and so we know what the first term value is. That's 3, so that we can substitute 3 here. And we've just figured out the common ratio to be 2. So the equation is going to be a sub n is equal to 3 times 2 to the power of n minus 1. Now, using geometric sequence equations, okay, to find a sub 12 for this equation, for the sequence represented by the equation. Okay, so let's break this apart. Okay, there are a lot of dots here. The first dot here, between 4 and 1, notice that it is higher on the line. It's in the middle of the line. So that means this is a multiplication symbol, even though it's just a dot. As opposed to this dot at the bottom, that is a decimal point. Okay, so make sure that you do not get those two mixed up. Now, how do I calculate a sub 24 using the calculator? Okay, so a sub 24, you need to simplify as much as possible first. Okay, a sub 24 is going to be 4 times 1.3. Remember, it's decimal point here, so this is going to be something that is together. It's 1.3. It's not 3 to the power of 24 minus 1. It's 1.3 to the power of 24 minus 1. And I know that 24 minus 1 simplifies to 23. And now I'm thinking, okay, between multiplication or exponents, which do I do first? Exponent is higher order of operation. That means we need to do this. So we need to calculate 1.3 raised to the power of 23. Now this is your phone calculator that you can use. This is you can do so by tilting your calculator sideways, and then you're going to get more extended calculator here. So what you need to do is type in 1.3 first. 1.3 is the base, so you would do 1.3. Okay, now we need to raise that to the power of 23. How do I do that? If you look at your calculator, and your calculator might be slightly different, but you would have something that looks like this: x to the power of y. So we have two different variables, and the operation is exponent. So the first number that we just entered, 1.3, is the x value. So then after you've done 1.3, you click x to the power of y button, and then you enter the exponent that you want. So in this case, 23. So then you enter 23. Then you need to enter equal sign so that the calculator will evaluate the value. Okay, if you enter the equal sign, and you should be trying this on your own, you should get 417.54. Okay, so can you try that right now and see if you get the same number? Okay, then once you've gotten that, then whatever that number is, I need to multiply that by 4. Okay, because multiplication comes after exponent, so you press multiply by, and then 4 again, and then it should give you 1670.16. Okay, so try this yourself to make sure that you are using your calculator correctly. Okay, so with that, I'm going to allow you to go back to the Desmos activity, card number 19 to 22 from the previous day. Okay, so I would like, the priority should be that you finish card number 19 to 22. Once you finish that, you should go back to the rest, all the previous cards, and make sure that they're all completed, because at the end of this class, I am going to be grading it as part of your classwork from last class as well as today's class. So make sure they are all done and none of the cards are missing. And if you need to correct any of them because you're not happy with the answer that you originally put, by all means, you should make any corrections with any new understanding. Okay, so now that we are done, we are going to change our pace a little bit, and we are going to be leaving sequence for now, and we are going to be going on to solving linear equations. Should be a review. Okay, so because this is going to be helpful for us to sort of go back to what we do when we come across this kind of thing. So first thing is, when you're being asked to solve, that means you're being asked to find the values of any variable, missing variable that makes the equation true. Okay, so we have 17 plus 3x is equal to 35. So how do I solve this? Well, you need to be considering what is being happening to the variable x. We're looking for the variable x. The first thing that was done to x was multiplied by 3, and then 17 was added. To figure out what x is, we need to go backwards as to what was done to x last. The last thing that was done to x was adding 17. That means we need to undo 17. How do I undo 17? It's adding 17 to this 3x. So we are going to be subtracting 17 from both sides, which leaves us with 17 minus 17 becomes 0. Okay, so you're left with 3x is equal to 35 minus 17. That's going to be 18. Okay, and then from here you're saying, okay, what is happening to x here? What is 3 doing to x? 3 is multiplying to x, so we need to undo multiplication. So how do we undo multiplication? That's going to be division. So we're going to divide both sides by 3, and that leaves us with x is equal to 18 divided by 3 is going to be 6. Okay, now when you have found your solution, it's really important that you go back to your original equation to make sure that your solution is correct. How do I do that? You just substitute this back into the original equation, and that becomes 17 plus 3, and instead of x, I am going to put 6 that we think is the solution, and we're asking ourselves, is this true? Is this equation true? Okay, so then let's evaluate what's on the left hand side and see if it checks out with the right hand side. 17 plus 3 times 6, so we have 17 plus 3 times 6 is 18, and 17 plus 18 is 35, and indeed 35 from left hand side is equal to the 35 from the right hand side, so I know that that is true. So this solution I know is correct. Okay, let's keep moving. Okay, so at this point I would like you to pause the video and see if you can solve the rest. Okay, this should be a review for you. If you are stuck, then just do your best, and then once you've given your best go, then come back to this video and watch the rest. Alright, so now we have 10 minus 2y is equal to 16. Again, you need to be thinking about what is being done to y. Y is first being multiplied by negative 2, and to that 10 is being added to it. So the last thing that was done to y was adding 10, so we need to subtract 10 from both sides, and you're left with negative 2y is equal to 16 minus 10 is 6. A lot of students lose this negative sign. Remember that negative sign or subtract belongs to the number that follows. Okay, so do not lose that negative sign, because those are very, very important, just as important as any of the other numbers. Now negative 2, what is negative 2 doing to y? Negative 2 is being multiplied to y, so we are going to divide both sides by negative 2 to get rid of that, so that this just becomes my giant 1, and it cancels out, and so on the left hand side you're just left with x. Y is equal to 6 divided by negative 2. 6 divided by 2 is 3. Positive divided by negative is negative 3. And again, I should go through the checking process to make sure that I'm doing it correctly. Okay, so here is my checking process. We're substituting y to be negative 3 into the original equation, so that becomes 10 minus 2. And notice I'm using parentheses for the y value that I just found is equal to 16. We're asking ourselves, is that true? Well, negative 2 times negative 3 is positive 6. And 10 plus 6 is indeed 16, so that checks out.